All right, let's just jump right in. Picture this. Someone hands you a single math problem, just one, and they tell you, hey, if you can solve this, you're a millionaire. How wild is that? That's right, a cool $1 million. I know, it sounds like something out of a game show, right? But this isn't some startup lottery or a lucky crypto bet. No, this is a very real prize for solving one of the deepest, most fundamental questions we could possibly ask about, well, everything. So what are we talking about here? We're talking about the Millennium Prize Problems. And believe me, these things are some of the toughest intellectual challenges, maybe ever. So here's the backstory. Back at the turn of the millennium, in the year 2000, the Clay Mathematics Institute put together a list of 7 of the most profound, most difficult, unsolved questions in all of math. And the goal? It wasn't just to stump people. It was to push science forward in a huge way to really define the absolute limits of human knowledge. Now here's the kicker. The current score, out of those 7 massive problems, only 1 has been solved. That leaves 6 just sitting there, waiting, each with that $1 million bounty attached. Okay, so let's crack open the case files on a couple of these intellectual heavyweights. I mean, what kind of problem is actually worth $1 million? Let's find out. First up is a real big one, a problem that doesn't just stay in the world of pure math. It bleeds right into our digital lives. It's called P versus NP. And at its heart, the question's actually pretty simple to grasp. If it's easy to check that a solution to a problem is correct, does that automatically mean it's also easy to find that solution in the first place? Think about it like this, a Sudoku puzzle. If I give you a finished puzzle, you can check if it's right in, what, a minute? Super easy. But trying to solve a hard one from a blank grid, man, that can take forever. It's incredibly difficult. So the P versus NP problem is basically asking, is that gap between checking and finding a fundamental law of the universe, or is there some secret shortcut we just haven't discovered? You know, is P the set of problems that are easy to solve, the exact same thing as NP, the set of problems that are easy to check? And that is why this is $1 million question. Because look, if the answer turns out to be yes, if P actually does equal NP, our world would change, and I mean overnight. The entire foundation of modern cryptography, the stuff that protects your bank account, your emails, everything online, it would just crumble, gone. But on the flip side, it would be an absolute game changer for AI, for logistics, for discovering new medicines. All these incredibly complex problems would suddenly become, well, easy. It literally defines the absolute limits of what our computers can and can't do. All right, next case file. We're going to shift gears from the digital world to the physical one. Let's talk about something called the Navier-Stokes equations. Sounds complicated, I know, but the idea is pretty cool. These are basically the mathematical rules that describe how fluids move. We're talking everything from the air flowing over an airplane's wing to the water swirling in the deepest parts of the ocean. The big question here is all about predictability. You see, can these equations always give us a smooth, predictable forecast of what a fluid is going to do? Or is there a point where they just break? Can they create these things called singularities? Basically, points where the math completely goes haywire and everything dissolves into chaos. Think turbulence on a plane. That's the kind of thing we're talking about. And believe me, the stakes here are huge. This is not just some abstract math puzzle. A solution would finally let us understand turbulence, which is one of the great unsolved mysteries in all of physics. Think about what that means. It would be absolutely critical for building safer airplanes, designing way more efficient engines, and making our weather forecasts, well, actually accurate for once. It's totally foundational to how we see the physical world. So 6 of these monster problems are still out there, unsolved, just waiting for a genius to come along. But what about the one that was cracked? Oh, this is where the story gets really, really interesting. It's called the Poincaré Conjecture. And this thing was posed way, way back in 1904. It asks a super fundamental question about the nature of 3D space. To put it simply, it's kind of like this. Imagine you have any 3D object. If you can wrap a cosmic rubber band around any part of it and shrink that rubber band down to a single point without it ever tearing or falling off the object, does that mean the object is basically just a warped sphere? For more than 100 years, nobody, and I mean nobody, could prove it. So you've got Poincaré asking this question in 1904. For almost a century, the absolute best minds in mathematics throw everything they have at it, and they all fail. Then, out of nowhere, in 2003, this reclusive Russian mathematician, Grigory Perelman, just
quietly posts his proof online. No fanfare, nothing. It took the math world years to even go through it and make sure it was right. But finally in 2010, the Clay Institute made it official. The century-old mystery was solved.
So there it was. The epic quest was finally over. Grigori Perelman was officially awarded that $1 million prize. He'd done it. He'd solved one of the hardest problems in history. And then came the twist. He said no. He turned down the $1 million. He also refused the Fields Medal, which is basically the Nobel Prize for math. For Perelman, it seems the money and the fame, they were just distractions. They got in the way of the pure beauty of the discovery. He just wanted the work to speak for itself. Incredible. You know, Perelman's story really gets to the heart of what these problems are all about. It's so clear they aren't just about a cash prize or getting your name in a textbook. They represent something so much bigger. When you step back and look at all 7 of these problems, a pattern starts to emerge. They all live right on the edge of what we know. They're these amazing bridges connecting pure math to physics, to computer science, to geometry. What they really do is shine a spotlight on the exact places where our current understanding of the universe just falls apart. And that means you can't solve them just by being a little bit smarter with the old tools. No, solving them requires coming up with entirely new ways of thinking.
To put it another way, solving one of these isn't just about answering a single question and moving on. It's about changing the entire intellectual landscape. It gives all of us, all of humanity, a new set of tools, a new way to see the world, and, maybe most importantly, a whole new set of questions for the next generation to obsess over. So, $6 million questions are still out there, waiting. They are the great, unwritten frontiers of science and math. The only question left is, which one of those frontiers is going to fall next? And who is going to be the person that changes everything?